Okay, so yesterday we went over the 5 reaction types. Okay, the 5 reaction types are synthesis, where you have 2 elements usually reacting to form a single compound. Okay, we talked about decomposition reactions, which are the exact opposite. A single compound is our reactant. Our products are 2 elements. Okay, we talked about combustion reactions, where a hydrocarbon, that is a molecule containing carbon and hydrogen, reacts with oxygen gas and produces carbon dioxide and water. And then we talked about the 2 replacement reactions. Okay, single replacement reactions involve an element, either metal or non-metal, reacting with an ionic compound. A double replacement reaction is 2 ionic compounds reacting with one another. Okay, those are what we went over yesterday. So what we're going to do today is kind of practice the balancing part. Okay, how we make sure there's the same amount of everything on the product side and the reactant side of a reaction. All right, we're going to continue to work on kind of the naming of things by looking at writing the reaction out in words underneath, right? And obviously then identifying the reaction types as we go along. Okay, so these ones here are not in your notes, but what I would like you to do is copy them down as we go through them. I'm going to go through the first 5 here, okay, and then I'm going to give you guys the opportunity to do the other ones. All right. Actually, I'm not going to do the first 5. I'm going to do 2 from the top and 2 from the bottom, so you see both types, both ways these kind of questions can be asked. Okay, so on our first one here, I start out with a compound, and it's breaking down, okay, into 2 elements. So what kind of reaction is that? That's a decomposition reaction. All right, so that's the first thing we do is rewrite the reaction type, decomp. All right, then I got to write it out in words. So this is a molecular compound, agreed? So what do I need in the name? Prefixes. Okay, so I need trinitrogen, okay, dioxide. And I put an arrow there. It's breaking down into what's this stuff? Nitrogen. Remember, I don't change the name of it just because it's a 2 here. It's still just nitrogen by itself. Okay, so it's just nitrogen. And same with the O2, that's oxygen. Those 2 are 2 examples of our molecular elements, okay, that are highlighted on our periodic table. All right, now I got a balance. In general, and this rule works about 90% of the time, okay, I start with the largest number when I'm balancing, except for combustion reactions. We talked about how they have their own set of balancing rules. Okay, but for all other types of reactions, I generally go with the largest number because most of the time, if I make that one work, the other ones fall into place. Okay, there are some occasions where that doesn't work. Right now, nitrogen is present in the highest number in this reaction. I've got 3 on this side, and I've got 2 on this side. So I've got an odd number on one side, even number on the other. What's the fastest way to turn an odd number to an even number? Okay, I could do the lowest common denominator thing. Yeah, I could do that. Or put a 2, which is essentially what I would have done if I was finding the lowest common multiple. Okay, so I'm going to double the odd number to make it an even number. 2 times 3 is 6. Okay, what do I got to put in front of this then? 3. What do I got to put in front of this? Jeez, my English is awful. Okay, and then how many oxygen do I have over here on the reactant side? 4. So what needs to go here? Okay, making sense? Ringing a bell from yesterday? Okay, for number 2, I've got calcium, which is a metal and an element by itself, reacting with iron 3 chloride. How do I know it's iron 3? Okay, because the chlorine is a 3. Okay, so if I'm writing this out, I got calcium plus iron, Roman numeral 3 chloride. Okay, and remember, I got that Roman numeral by doing this. Chlorine's a -1, so there's 3 negatives. That means this iron's got to be 3 positive. Okay, and that's going to give me, what am I going to call this? Iron. Do I need to put a Roman numeral after it? No. I see that mistake often, though. You only need a Roman numeral if it's in an ionic compound where it has a charge. When something is by itself, its number of protons and electrons are equal. So it doesn't have a charge anymore. Okay, so this is simply iron, and it's over there with calcium chloride. Thank you, Max. I was just about to ask you to do that. Okay, is that making sense to everybody? Okay, so those are the kind that we dealt with yesterday where you're given the formula and you got to write out the names. Something that's new is like these ones, where I'm going to give you the names and now you got to write the formula. See how important the naming is? Okay? If you can't do the naming, like that's kind of the fundamental skill, okay, of being able to use and manipulate chemical reactions. Right? It's like if you learn how to play soccer, the first thing they teach you how to do is dribble. Okay? Right? Keep the ball, keep control of the ball when you're running. I assume anyway. I actually can't stand soccer, but I don't know why that popped into my head. Okay. All right. So copper 2 nitrate, okay, reacts with magnesium. All right. So I got to start writing that out. Copper 2 nitrate, Cu 2 plus NO3, okay, is -1. So I drop and swap. So I'm going to need brackets here. The 2, it's going to react with magnesium. So that's just Mg, okay, all by itself, right? It's not with anything. Okay, to form magnesium nitrate, so Mg with NO3. This is a -1, and this is a +2. Okay, and remember, I got to recognize when I write something down. Is that ionic? Okay, I better swap and drop. Okay, it's one of those things we just got to recognize. Okay, put the 2 there, and copper. Okay, so now I've got my reaction written out. Now it's time to identify the reaction type. So what kind of reaction am I looking at here? Single replacement. Incidentally, because I forgot to do it on number 2, that was also a single replacement reaction. Okay. All right, so we got a single replacement reaction. Now we need to balance. Done. Okay. It's actually already balanced. If I'm looking at copper, there's how many copper here? 1. Okay. And there's 1 over there. How many nitrates? And 2. Okay. And 1 magnesium and 1 magnesium. So it's already balanced. Okay. Now, here's the thing. Once in a while that's going to happen. If that's a fill-in-the-blank question on a unit exam, what do you need to put in all the blanks? Because if you don't put anything in the blanks, I don't know whether you didn't do the question or whether you knew it was balanced. So indicate to me you knew it was balanced by writing 1s in all the blanks for a fill-in-the-blank balancing question. Is that okay? Just I see people do that and they come to me, Mr. Quader, it was already balanced. Yeah, but you didn't write anything. How am I supposed to know that? Okay, so make sure if it's a fill-in-the-blank question, you actually write something, okay, even if it's all balanced. Okay, and then for number 7 here, we got C12H26, which has really long name, so I just wrote it that way. Okay, is reacting with oxygen. So I'm writing out this reaction here. Oh, 26, not 16. Plus oxygen gas. What does that look like? O2, right? This is where that highlighted stuff becomes important, right? I look on there and I go, oh, that one needs to be a 2 or that one needs to be an 8. Okay, to produce carbon dioxide and water. What kind of reaction is that? Combustion reaction, right? Okay, we have special rules for balancing combustion reactions. Rule number 1, balance in alphabetical order. Rule number 2, the rule of 2. Do I need the rule of 2 here? Okay, let me review the rule of 2. The rule of 2 says if you have an even number of carbons, start your balancing with a 2. Do I need a 2? Yes, 12 is an even number. Okay, so I need to start my balancing with a 2. That's what the rule of 2 is. Okay, all right. 2 times 12 is how many? 24. All right, so I got to go over here and put a 24 in front of carbon dioxide. We're going to have some big numbers to deal with. Okay, 2 times 26 is 52. So what times 2 will give me 52? 26, right? Okay. Luckily, it usually works out that way. Okay. Now I got to balance my oxygens because it's last alphabetically. So 24 times 2 is 48. Okay, plus 26 more, 74, right? I think so. Okay. Is that right? I think it's 74. 74. So we are looking at 37, right? Yeah, 37 times 2 is, I think so. You can double check my math. I shouldn't do math in my head. It's a very bad idea. Okay? All right. All balanced? We're going to say that Mr. Cudder's math was okay on that one. I'm pretty sure it was. Okay. Probably on a test, I wouldn't give you one with such big numbers. Okay? I just made this one. On a test, it would probably be smaller numbers, so you could easily do the math in your head. Oh, of course, you would have a calculator as well. Okay. All right. Questions on what we're doing here? Okay. So I want you to do 3, 4, and 5 here, and then we'll go over those together, and then we'll have a look at 8, 9, and 10 on the bottom. Okay, let's have a look at number 3 here, just to see how we're doing. Okay, so we got, what kind of reaction is number 3? Combustion reaction. Okay. All right, so we got hexane reacting with oxygen. Okay, and that's going to give us carbon dioxide and water. And guys, anytime you see H2O, HOH, just call it water. That's what it is. Okay? Don't bother trying to figure out a technical name for it. You can use the common name for that one. All right. Now I've got a balance. So I got a balance alphabetically. Do I need the rule of 2 here? Yes, I do. 6 is an even number. All right. So 2 times 6 is 12. So I got to go over here with the 12. Okay. 2 times 14 is 28. So 14 times 2 is 28, and now I got to total up my oxygens. Okay, I've got 24 oxygens here, and I've got another 14 here for a total of 38. Everyone with me so far? All right, 38 over 2 is 19. All right, questions on that one? Okay, how many people have done number 4? Okay, let's go over number 4 too. Okay, I've got chlorine element, non-metal, reacting with lithium, metal, okay? And that's producing lithium chloride, which is an ionic compound. What kind of reaction is this? It's a synthesis reaction. Okay, now I mentioned yesterday that I trick people on a quiz with something like this every semester, okay? This would have been another example of one of those kinds of questions. I put the non-metal first and the metal second in the reactants. And you got to remember that when you put a metal and a non-metal together, that's an ionic compound, and as a result, the metal gets listed first in the compound. But there's a real tendency for people to write it in the order it was in the reactants. Okay, everyone follow me there? Think about what things are going together. If it was a molecular compound, you can do whatever order you want, right? But in an ionic compound, you got to remember metal goes first. Okay. All right. So to write this out, we got chlorine plus lithium gives us lithium chloride. Okay, and again, guys, what do you not see any of in here? Right, well, except for hexane. Should have been there. Okay, no capital letters. Okay, we got to remember that. Now we got a balance. Looks like the only thing right now that's out of balance is chlorine. There's 2 over here, so what do I do with over here? Put a big 2 here, right? Okay, remember, I can't write the little numbers because that'll change the chemical. I can only change the amount of chemical. When I do that, it gives me 2 lithium, so I got to go back over here, right, and write a 2 in front of that. Okay, how many people have done number 5? Okay, I'll give you another minute or 2 on that one. Okay, so number 5, I've got magnesium fluoride, which is an ionic compound. Okay, is reacting with cobalt. Which cobalt? 2 or 3? Cobalt 3. Okay, cobalt 3 nitrate. Okay, and that's going to form magnesium nitrate, which doesn't need a Roman numeral. Okay, and cobalt 2 or 3? 3. If you start with cobalt 3, you have to have cobalt 3 on the other side. You can't change the kind of cobalt you have in a chemical reaction. So if you figured out the Roman numeral on the other side, you don't have to figure it out again. It'll be the same one. Okay, cobalt 3 fluoride. What kind of reaction is that? double replacement. Right. Okay, we got two ionic compounds reacting with each other there. All right, so now we got a balance. It looks to me like I could pick either fluorine or nitrate first, okay, because they're present as a 3. Okay, both of them at least on one side. All right, what's the lowest common multiple of 2 and 3? 6. Okay, so I want to make 6 nitrates, so I'm going to put a 2 there. All right, now I'm going to go over here and make 6 nitrates by putting a 3 there. Next thing I want to do, all right, when I did that, it gave me how many magnesium? 3. So I got to go back over here and make sure I have 3 magnesium. When I do that, it gives me how many fluorine? 6. So I'm going to go over here and make sure I have 6 fluorine by putting a 2 there. That gives me 2 cobalt. Hey, how about that? Okay, now my cobalt's balanced too. Always a good sign when you get to the last one if it makes the last thing work. Okay, if it makes the last thing go out of balance, bad news for you. You're going to be starting over. Okay. Now, when you get to these ones here, okay, for 8, 9, and 10, if you can't get it to balance, chances are you have swapped and dropped something incorrectly or have forgotten to do it entirely. Okay? If you can't make the equation balance, chances are one of your small numbers isn't right because of an incorrect swap and drop. Okay? So if you run into that problem, first thing you should do is go back and check that you've swapped and dropped your stuff correctly. Okay? All right, I'll give you a few minutes on those 3. Okay, so on number 8, we've got lithium nitride, ionic or molecular? It's ionic. Lithium is a metal. Okay, so I know I've got to do the swap and drop. Okay, on this one, nitride is -3, lithium is +1, so I'll have Li3N for that compound. And it says it breaks down into nitrogen and lithium. Okay, what's nitrogen look like? N2, right? Okay, that's one of those ones, again, where we got to be looking at the periodic table and checking for special elements. Okay, and lithium. Lithium is not special. We don't mean to hurt its feelings, but it's not. Okay, it comes as a single. Now we need to balance the whole reaction. I could start with lithium. It's present in the largest number, but if I do that, I'm going to have to change it afterwards when I balance nitrogen. Why is that? Well, nitrogen's a 1 over here and a 2 over here, right? So if I balance the lithium first, then I come back over here and go, oh, I put a 3 there and a 1 here, it won't work. I know I'm going to have to put a 2 here to balance the nitrogen, so I'm going to start with it. Okay. When I do that, it gives me how many lithium? 6. Okay, what kind of reaction is that? Decomposition. Okay, so there's a lot of little details to be mindful of when you're writing a chemical reaction, and it's those nitpicky details that end up costing you marks if you forget one. Because if you're doing something like this, okay, let's say that this is a question on an assignment or a test, and I forget that nitrogen is a 2. Now I write my reaction like that, okay, and I look at this and go, oh, okay, I need a 3, I need a 3 there, and now my reaction's balanced. Except it isn't, because that's not the right reaction. So now I've gone from what I had before, which would be 4 out of 4, to now essentially 1 out of 4, maybe 2. All right, everyone follow me there? So it's really important for those little nitpicky details. Danielle, question? Because nitrogen is one of our special elements that when it is by itself comes as a 2. Right? We highlighted it on our table. Remember to keep putting that down. Okay, so that's what it should look like then. Okay, how many people have done number 9? All right, let's go over number 9 as well then. Okay, so we got hydrogen sulfide, ionic or molecular? Ionic. Hydrogen's listed first. Hydrogen acts as a metal. Okay, so I got to drop and swap. -2 + 1, so we got H2S. Okay, and that's reacting with calcium hydroxide. Here's calcium, that's a metal, so I know I've got an ionic compound. And hydroxide's a polyatomic ion with a charge of -1. When I drop and swap, I got to put that in brackets. Okay. It's going to produce calcium sulfide, also an ionic compound, 2+, 2 minus, when I drop and swap, that one's set up okay. And hydrogen and water. Now, I'm going to write water like that. Why am I going to write water like that this time? Here? Right, it's a double replacement reaction. It helps me trace where OH went. If I write that as H2O, I might, because that's just me, I might get mixed up and forget where everything came from when I'm doing my balancing. I always find that if the question gives me OH on one side, I should leave it as OH on the other if it goes into water. Right. Okay, what kind of reaction am I looking at? Double replacement. Okay, and now we've got a balance. I would say we should start with hydrogen or hydroxide because looking at this, I know I'm only going to have to add one number. Okay, hydrogen's a 2 over here. What does it need over there? A 2. And when I do that, does that make my OH's balance? It does, and everything else is a 1. Okay. All right, again, guys, the little nitpicky details. Okay, if we forget to put these brackets on here, okay, and instead we write CaOH like this and leave everything else the way it is that reaction correct or not? It's not. Okay, it would go from 4 out of 4 to 2 out of 4 because now it isn't balanced either. Okay, not only have you not written hydroxide, because I don't know what this stuff is, okay, calcium with 1 oxygen and 2 hydrogens, I don't even know that that exists, okay, and now it also isn't balanced because now I only have 1 oxygen over here and I have 2 over here and it's not working anymore, okay, so that little detail of forgetting to put in brackets, okay, again, ends up costing you big marks, so you really have to be detail oriented when you're running through these. Hydroxide, because it's in our table of polyatomic ions. Up here. Okay. Hydroxide is OH. Okay. If it's oxygen, I think I know where you're going with this. Oxygen by itself, let's say in a ionic compound, that's oxide. If I have hydrogen listed second, like let's say CH4, like this, that's not hydroxide, that's hydride. Oh, I just couldn't find it on there. Okay. All right. How many people are done number 10? Okay, let's go through that one too. Okay. Number 10 is one of those ones, again, where we have to know which elements are special on our periodic tables. Phosphorus is a special element. Yes, it is. Comes as a 4. Okay, P4 reacts with oxygen, O2, okay, to produce triphosphorus dioxide, P3O2. What kind of reaction is that? Synthesis reaction. Balancing. What's present in the largest number? Phosphorus. So let's balance that first. I got 4 on one side, I got 3 on the other. What's the lowest common multiple? Okay, so lowest common multiple is 12, right? Of 3 and 4. That's the first number they both multiply to. All right, so I'm going to put a 3 here. 3 times 4 is 12. I'm going to put a 4 here. 4 times 3 is 12. All right, that gives me 8 oxygen. So I got to go back over here, put a 4 there, and I'm good. Starting to make sense? Okay, so you just got this worksheet here. Okay, so you can work through that if you want to check how you're doing. Okay, there is a key on the website. All right, so you go to my website there, go to Science 10 stuff, and then in the chemistry folder, okay, there should be one that says keys to all reaction worksheets. Keys to all reaction worksheets right here. Okay, so if you click on that, okay, the keys for all my reaction worksheets will be in there, including this one. Right, you can kind of check and see if you're doing them right as you go. If you get one wrong and you can't figure out why, okay, come and see me. If there's one that you're looking at the key and you're like, I can't see how that would work or how I would get that answer, just ask. We'll go through it on the board. Because chances are, if one of you doesn't get it, Probably a lot of you don't get it, and it's worth going over together. Okay, so don't be shy about asking. Okay, guys, a good question came up here, and this question usually comes up on question number 8. In terms of naming, as well as it's kind of a tricky balance, but in terms of naming, a lot of times people notice that these look like polyatomic ions that are in their chart of polyatomic ions. But the thing is these are only ions if they're in a compound with something else. Since this is not in a compound with something else, it's its own compound and needs to be named as such. So instead of sulfite, this is sulfur trioxide. Okay, does that make sense to everybody? Right? It's only named as an ion if it was, let's say, with calcium. Then it would be calcium sulfite. Okay, but because it's by itself, it's sulfur trioxide. Okay. Any questions coming up that you'd like to go over? Okay, keep going then. Guys, mistake on my key. Number 3, I obviously can't swap and drop correctly. Okay, because on my key for this, I wrote aluminum oxide looking like this. Which is clearly not right, as aluminum oxide should look like that. Okay, so when we're looking at this one on the key, we should have aluminum reacting with oxygen to produce that stuff. Okay, and then we would need a 3 here, a 2 there, and a 4 there. All right, so correction on the key. Key is not right for number 3.